Okay.
Okay, sir.
Yeah. Okay. So as I told that you have quiz 2 this week, so we'll not do too much today. Like as it is, week 9 is not much. We have covered K means. That is the main topic, and we have covered it in detail. So I hope K means is clear to everyone, right? What we discussed on Monday. Any question on K means? The theory, the
No, sir.
yeah, good. Okay, so that was the main thing. Apart from k-means, there are some other clustering techniques. We will approach one of the techniques today that is called as hierarchical, or the more popular name is agglomerative clustering. Okay, so that's what we'll see today. It is again very simple. Code wise, it is same. Like you just have to, instead of k-means, you have to you instead of k-means, you have to just replace it with agglomerative. That's all for the code. Let's try to understand how it works conceptually as well. Okay, so yeah, so let me start here. So what does agglomerative clustering do? It's very simple. Again, here you have to specify the k, right? Which is number of clusters. And k means also we have to specify how many clusters I want. Same thing for here. So you specify
Sir,
this.
you shared the screen.
Oh, sorry, sorry. I'll just share it. Yeah. So now it's there. So yeah, so I was saying that in agglomerative clustering also, just like in k-means, you have to specify, right, how many clusters you want. Like last time we experimented with 3, then 5, then 7, and so on. The same thing you have to do for agglomerative clustering also. You have to specify, okay? So k will be your number of clusters. Number of clusters. Now, how does this work? It is very simple. Again, it compares distances and all, okay, between points and means. Those similar concepts are there. But instead of assigning all the points to, like, say, k is equal to 3, so instead of assigning all the points to 3 clusters at once, it will do a little more of a iterative process, right? It will work for more iterations. It will go more slowly and then do the assignment, right? So let me give you one simple example. So, for example, we have 5 points, right? So let's say we have 5 points. One point is A, second point is B, third point is C, fourth point is D, and fifth point is E, right? So these are 5 points. Now what we'll do is we will basically, instead of computing some means, in k-means we compare means, right? We take some initial means and then we compare distances. We will compare distances amongst all these points. Okay, so we'll do point-wise distance measure. Point-wise distance measure. Now, what does this point-wise distance measure means? It's very simple. It just means that you compare the distance AB, right? You compare the distance AC. You compare the distance CD, right? You compare the distance DE. You compare BD, BE, right? And you have AE as well, right? So all these distances, all the distances between all the points, we'll compare. It can be Euclidean or anything. That is not a problem. Any distance measure, just compare the distances between all the points. Once you have compared the distances between all the points, you see which 2 points are closest, right? So what do I mean by closest points? Minimum distance, right? So we'll see what are the closest points. So, and what are closest points? Closest points are nothing but minimum distance. Okay, that means let's assume AB is the closest, like the distance between A and B is the least. So what we'll do now is, this is, let's call this as step 1. So step 1, we have all the points. In step 2, what we will do now is we will simply just merge these two, A and B, because they are close, right? So we will merge closest points. So what do we have now? We have a cluster which is AB, because we have merged them, and all the other points which are there, which are C, D, and E, we'll keep them aside. Are we clear so far and what we have done? Any question on this?
No, sir.
So instead of taking any means and all, we just compare the distance between all the points. And obviously, we know, right? In k-means also, whichever points were similar, they will be in the same cluster, right? Same thing we are doing here directly. We are comparing distance between all the points, and whichever point has the least distance, we have just merged them into one cluster. At every iteration, we'll just do one merge. Okay, we are not going to do more than one merge, only one merge per iteration. Okay. Now what we'll do is we'll again merge the closest points in the next iteration. But the problem is, now we have already these distances, right? CD we have DE, and we have CE also, right? So CE was also here. I forgot to write that. So we have all these distances. But we have to also see, right? Are they similar to these A and B? We have to also see these distances. So what we'll do now is we will do next step of distances, where we will do again distance. And this time what we'll do is we will measure the distance of every point from this AB as well. So we'll take distance of AB, sorry, AB with C. Okay, so AB with C. Similarly, we'll take AB with D and we'll take AB with E. All the distances. Okay, so AB with D, and finally we'll take AB with E. Right, and of course we have those initial distances which are already there, so that we will also consider these ones. These are already there, so nothing to worry about this, and we will take this one.
Are we discussing week 9?
Yes, week 9.
Okay. Okay.
So last class we discussed about k-means, right? So we are today talking about another way of clustering, which is called as agglomerative clustering. So what is happening here is, instead of taking centroids and means, right, we are comparing all the points with themselves only. So all the distances we are measuring earlier was with some mean, right? Which mean is closer to which point. Now we are comparing the distances of all the points with themselves. So what we saw is that we computed all these distances, and we saw that distance of AB was least, right? So since AB has the least distance, that means A and B are similar points. So we merge AB into one cluster. At every iteration, we will merge one cluster, right? One point, like one point with the previous points, we'll be merging at every cluster. Once we have merged AB, AB is one cluster now, and these 3 points are now independent. So
Now
what?
we will compare AB to C, AB
Yes,
to D,
we'll
AB to
compare
E.
with AB, right? So these
And
three we already have
whichever is
compared.
least, we will again add in this.
Again add a point, right? One every iteration, one merge we'll do. So now we have what distances? We have distance of AB with C, we have distance of AB with D, and we have distance of AB with E. So these 3 distances we have now, right? And the earlier distances, obviously we can't discard them. These are also there, CD, DE, and CE, right, which are already there from before, so we carry them. So now let's suppose we'll again see whichever is the minimum distance from here. So let's assume the minimum distance is let's say CD. CD is minimum, right? So what we'll do now, since CD is minimum, we have AB already, which is into one cluster. Okay. Then we have CD, which is also there. So now we'll merge CD because CD has the minimum distance. So CD becomes one cluster, and the point E, this becomes one cluster. Okay. So this is where we have completed at the end of second iteration. We have one cluster which is AB, we have one cluster which is CD, and the third one is E. Now, how do we know when to stop? So when to stop, it's very simple. You have to give this hyperparameter, right? What is the number of clusters you want, which is a business problem. Last week also we discussed that k-means is a business-centric problem, right? We have to understand how many clusters we want. So in the same way, let's assume k is equal to 2, right? Let's take k is 2. That means I have to do one more merge, right? Because I have 3 clusters right now. I have to get 2. So I have to merge E as well. So what we will do now is, at step 3, we again compute distances. Now it's very simple. There are only 2 distances to compute. So distance of AB with E and CD with E, right? So we'll do the same thing. AB with E, I think we already have, right? Yeah, we have it here only. So we can just carry this forward. And the next one, CD with E, that we will compute, right? So instead of AB, now like I can replace it with CD, right? So this is there, right? So now we have
How
computed. Yeah,
how the distance of AB to C will calculate? A to C and
yeah,
C
I'll
to
come to
C?
that. Yeah, that's a good
Hmm.
question. So basically, here the distances are very simple, right? Direct Euclidean distance,
Yeah,
nothing.
yeah, yeah. But how
Here,
to
what we
do
will
that?
do is, so let's just take one example. I'll write it here only. So let's suppose we are computing distance of CD with E. So what we'll do is, this will be the mean, right? Mean of C with E
Yeah, that
and
I wanted. Yeah,
D with E, right? That's what we'll do.
I mean of that.
Mean of that, yeah. So first we'll compute the distance of C with E. So basically we already have that, right? So we have this here and we
Yeah.
have this here. So we'll just take the mean of this. That will be our average
Hmm.
distance. Okay. So I'll just
Hmm.
write it here. These are average distances when you watch. Average distances.
It means we are
We have
carrying the
everything.
distance. Already we
Yes.
are carrying the distance, just
We
we
are
have to
carrying the
manipulate.
distance. Yeah,
Yeah.
yeah, yeah. We are just
Yeah.
carrying. Initially, in the first step only, we have everything. We'll just do some merging and averaging. That's all in the upcoming step.
Hmm. Okay.
Yes. Okay, so this can be one end-term question. Like suppose I ask you how many times do we have distance computation? So only once. Okay, because we are computing distance only once. Then we are just averaging, right? So only one computation of distance is happening in the first step. Okay. So yeah, this is done. So we have done this merging. Yeah. So now let's assume the CD was having less distance. So what we'll do is very simple. We'll just merge the CD and E, right? So AB will remain as one cluster here, and the second cluster will become C, D, and E. C, D, and E, right? Because CD distance was less than AB distance. That's why. Okay. So now we have seen that we have 2 clusters. We have given all the points in 2 clusters, and we also know that our n clusters is 2, right? Number of clusters is 2. So we know that we have done our job, right? So that means we can say AG clustering. So agglomerative is also short form as AG clustering. So AG clustering has converged. Okay. So now we'll stop. Okay. That's all. Now this stopping obviously depends on how many clusters are there, right? So if, suppose I say n clusters is 5. So if n clusters is 5, that means I already have 5 clusters, right? So I don't need to even do anything. It has already stopped here. If I say n clusters is 4, so I'll stop here, right? So the stopping criteria is very important. It depends on how many clusters you want. So this parameter decides the stopping criteria. So I'll just write that k decides the stopping criteria.
If it is 3, then how many times it
Yeah,
will
let's run that
3?
as well. So if it is 3, first step, again, all the distances, least distance was AB, so AB got merged, right? So we have 1 here, 2 here, 3 here, 4 here. Next is, again, we compute distance of all these 3 which are already there, and then we compute distance of everything with AB. So what we found out here was CD was the minimum, right? So what we'll do is AB remains, we merge CD, and we have E independently. So now what is my cluster? My cluster is AB, CD, and E. These become my clusters. So E will now be a cluster.
At each iteration, we have to count the number of clusters.
Yes, yes, as each iteration, and you have the lesser the number of clusters, the more the iterations, because we have to do more merges. More the
Yeah,
number of
yeah.
clusters, we'll do less iterations.
Hmm.
Okay, but the process remains the same. Compute distance, pairwise, then you measure the least one and just merge it, whichever is least distance. Okay.
Correct.
So that is the logic. So any questions on this? I think it's a pretty simple algorithm, but it's quite a useful one. This is more used in, if you take in degree level, there is a course called bioinformatics. If you take that course, you will see this agglomerative is used a lot inside that. One more use case is you in speech technology, when we have to identify which speaker spoke when. It's mostly for subtitles. That is also where this is used quite a lot. So these ABCDEs become speech vectors. Okay, so speech is vectorized into numbers, and we compare whose vectors are similar. Obviously, the person who speaks the same dialogue 2 times, his embedding will be similar, right? Because his pitch and voice, everything is similar. So we use this to merge that. So if you're in degree level, if you take those courses, you will come across this quite a lot, and it's a very useful technique.
This watch it goes go up, slide up, slide up.
Slide up, yeah. This is the old one. This is the old one.
Okay.
Yeah,
Yeah, already we discussed
yeah,
last
yeah.
time.
This is the same one. So this I'll just name this as week 9 collab, right?
Okay, okay, okay.
Yeah, yeah. This is week 9.
Correct.
Okay. So this
Sir, what is the difference between k-means and agglomerative clustering?
the working, right? So in k-means, what you were doing in k-means, what you will do is you will just take randomly 2 points as means, right? Then you compare the distances of that point, the mean, from every other point, and whichever distance is less, you assign it to that cluster. Here we are not comparing any mean; we are comparing the points with themselves only. Right, so there is no mean here, right? So mean centroid, if you remember, we were talking about centroids, right? So these one, the cluster centers, which we saw last class. So this was what we were comparing, right? So where is it gone? Yeah, these means, for every cluster we had a mean. So here we don't have any mean, because we are basically just comparing the distances between each point. Okay, and whichever points are similar, they will have less distance. Those points we are merging into one cluster. That's how it's working. Okay, so no means inside this.
Okay, sir.
Yeah, are you clear with the way it's working? Like, this process is clear, right? This one which we just discussed, how the merging is happening, average of distances. So that is clear, right?
Yes, sir.
Yeah, great. So for agglomerative, please
Sir,
prepare the theory well as well, because for the end term, the theory will be important for clustering. Okay, because the coding part is same for all of them. So you please focus on the theory, like how the algorithm works. This you should be clear with. Okay.
sir,
Yes.
sir, show the that that color.
Yeah. Yeah. One
Yeah,
second.
sir. Yeah, yeah. Okay, okay. I'm telling. Sir, here I know, sir. This AB is the minimum distance. So, sir,
Yes.
CD, sir. I didn't got this
No, no.
answer.
See,
Got it.
here AB was minimum, so you merged it, right? So this is clear. Now, in next iteration, what you do is AB is now merged. So what you do is you compare distances of every point with AB. So you compare distance of AB with C, you compare distance of AB with D, you compare distance of AB with E, right? Because now AB is one single point. Then what you do is the other point, you have to compare these also, right? And these are already compared. You have a distance between C and D, you have a distance between D and E, and you have a distance between C and E, which is already there. So now you compare all these distances and see which one is minimum. So for our example, we have taken CD as minimum. So CD gets merged. Okay.
No, sir. One thing.
Yeah.
Uh, so means when we are doing AB with C and AB with D, we got greater than
Greater
this
distance. Yeah,
CD.
yeah, yeah.
CD was
Exactly.
the minimum.
Exactly. Yes, yes.
Okay,
Exactly. So basically, for example,
okay.
like if you want to take it numerically, this one, let's say, is 10. This one was 11. This one was, let's say, 12. This one was 5. Right? It's like that. Okay. These distances are larger. This distance is smaller. So we'll merge this. Okay. Yeah. Yeah. Any other question?
If the
No, sir.
distance with
Continue.
AB with C, if distance with AB with C would have been least, then
Yeah,
the
then we will do this. Then this will happen.
ABC will be there,
ABC
and
becomes a cluster. Yes, yes. And in the next
okay.
iteration, we will compare distance from ABC to D and ABC to E from the 3 points. And we'll take
Okay,
three averages there, like average of
okay,
A to B, B to D, and C to D.
mm,
That we will do.
okay, okay, fine.
Okay. Yeah.
And in case first clustering ABC and second one is CD, then the distance will be how the averaging will be done.
First cluster is ABC. Second
ABC
one,
and second is CD. Then
second is
distance,
CD.
yeah, the distance between ABC and CD, how they will calculate A to
But
B.
no, no, then we will not merge anymore, right? Because now our clustering is over only in that case because we
No,
only
no,
have two clusters.
no, in this case, no.
Okay, okay, in an example. Okay, fine. So if
Yeah,
you have,
how to calculate 3 by 2.
so suppose you have ABC here,
Mm-hmm.
right? And suppose you have CD here. Not
Yeah,
CD,
yeah.
DE. C is already there. So DE.
Anyway,
Yeah,
yeah.
DE here. So then what you will do is you will compare A to D, B to D, C to D and get an average. Okay. So let's write it down. Suppose the average of everything with D is 2, right?
Okay,
Then
okay,
you compare A to E, B to E, C to E, and let's say the average comes out to be 4.
okay.
Okay.
Cumulative average.
Yeah.
Again average, no? 2
Again
to 4.
average. So now my final
Yeah.
distance is 3, the average of these two.
Got it. Okay, okay, got
Yeah,
it.
so two steps of averages. One was
Okay.
average of all these with this, then average of all these with this, and then
Mm.
the average of both of them to get one.
Average of average.
Yes. But in the end, see, the main thing is in the end, the distance that we get, that should be a scalar value because we have to compare a value, right? So we can't have a vector there.
Yeah, that's why I'm asking. Yeah.
Yes,
Okay.
yes. So we'll always average. We'll do multiple averages and get one scalar value, and we'll end up with that in the end.
Mm. So single code will work for all these
Single
things.
code, yeah, yeah. Code will be single. It will
Mm.
automatically do that. sklearn will
Okay.
automatically do the comparisons. Yes, yes.
Correct.
Just 1 minute. I'm just coming. Yeah. Yeah. So any other question on this? All good with the algorithm, like how it's working?
Yes, sir.
Okay. So let's now understand there is a diagram, like there's a specific way of visualizing agglomerative clustering, and the diagram is called as dendrogram. So let's see how that works, right? We'll compare it to the algorithm. It's nothing, it's just a representation. So dendrogram. Dendrogram. Yeah. Okay. So dendrogram, what it's doing, let's look at this dendrogram. Yeah. So let's look at this. So what this is doing is very simple. It is just showing you how the mergers have happened, right? So what is happening here? A and B were the closest, so they got merged first. Then E and F were closest, so they got merged. Then E and F we compare again. E and F, the EF cluster was very close to D, so they got merged with D. So now my cluster becomes DEF, right? Then this whole DEF, it was close to C, so my cluster became CDEF. And then in the end, we had two clusters. One is AB and one is CDEF, right? So it is basically just showing you the stepwise how it is merging. So can we do one thing? Can we construct a dendrogram for this one? What we just did right now. Can we construct a dendrogram for this? So let me
Yes, sir.
open something where I can write. So maybe a Word document. Let's try to create a
Yeah.
dendrogram for this.
Some drawing tool is required.
Yes, yes. I'll do it with this. Yeah. Okay, so we have 5 points. Again, I'm drawing it with my cursor only, so it won't be very clear, but it's fine. Yeah, so we have 5 points. One is A, B, C, D, and E, right? So let's create an endogram. So let's see what will get merged first. Let me just mark the points here so that we can draw it here. So A, B, C, D, and E. Yeah. So can you tell me how it will begin? AB, right? First we saw that AB is getting merged.
Yes, sir.
So this
AB.
becomes my first endogram. Then what was merged? CD, right? CD
CD.
is next. So this becomes my second part. Then we merged AB with E, right? So what we will do is we will have AB here,
And E.
E here, right? So this got
Hmm.
merged. And finally, we have to, like in the end, this is the end. The clustering is over, but we have to join the final clusters as well in the dendrogram. So what we'll do is we'll just draw this. No, not this, sorry. We'll take a line from this
Top, from top.
top, yeah, because this is the final cluster and the second one is this, right? So we'll just take these two and just join them up. Okay.
Hmm.
So how do
Hmm.
we read this? We had AB first, which got merged, then CD got merged, then AB and E. So this got merged, and finally this was one cluster and the CD was one cluster, so they got merged. This is the last one, right?
So two clusters are there.
Two clusters, yeah. So in the end, this branch gives you one cluster, and this branch gives you the other one.
Hmm.
Okay, so two clusters. Okay, so this dendrogram is very useful, and it is it gives you an idea of how the merging happened. So it is very useful for visualization. Just like in k-means for elbow method, we draw that line chart, right, to visualize the inertias. So here in hierarchical, we draw this dendrogram to visualize. Okay, so this you should be clear with, like how it is created. Like we're not required to draw it, but if a dendrogram is given in a question, we should know how to interpret it, right? Like which clusters got merged first, which got merged in the end, how many clusters are there in the end. That we should know.
Correct.
Okay, one more example. Let's take just one more. So,
Sir, these two circle indicating K values.
which one?
Sir, in sir
The
here.
circle? No, no, no. Circle was just for showing. The circle is not a part of it. Okay, this should be.
No, sir. That means these are K values.
Yeah, yeah. K values. Yes, yes. Two Ks. Correct, correct. K values. Yes.
Okay, sir.
Okay, let's take one more example. Now we have 6 points. So let's do A, B, C, D, E, and F. Okay, A, B, and C, then D, then E, and then F. Now the clustering is very simple. You have AB, you have CD, you have EF. Three clusters. Okay. So how do we merge? First we merge
AB.
AB, then we
C.
merge CD, then we merge EF, right? And then
EF.
we have to basically merge all of them. So we now have three branches, right? Because of three clusters. One branch is this, other branch is this, and final branch is this, right? It will be straight lines, of course, but this is the branching. So now we can know that there are three clusters. This is one cluster, this is one cluster, and this is one cluster. Okay. And if you see in the previous one where we had two clusters, there were only two branches of the final one. This was the first branch, and this was the second branch. Now, because we have three clusters, so we'll have three branches here, which will indicate the number of clusters. So if a dendrogram is given and if the question is how many clusters are there, so I think with this counting of branches from the top, you can identify how many clusters.
Yes, sir.
Okay, so yeah, that is it. So I'll just see if I can paste this inside the collab so that it can be stored there. And you can have it in your notes directly. Would be better. Yeah, it's here. So I think now we can see this, right? Visualization also. Okay, so I think any other question on this? All good. So then we can see the implementation quickly and then we can wrap up and you can prepare for your quiz too.
Okay, sir.
Yeah.
Just this even case, how only two branches are there?
Which even case? This one?
The first one, yes, ABCD, the odd case, sorry.
No, there are three branches, right? This is the first branch. This is the
Above
second
one,
branch.
above one.
Above one, two branches. Yeah, these are the two, right? 1 minute. Let me erase this. That will be a little clear. So you have to see the branches from the top, right? So once you see it from the top, you can see that this is one branch, right? And this branch contains 3 points, which is this point, and this point. Okay. This is my second branch and it contains a cluster of 2 points, which is this and this. Okay. That means K is equal to 2. There are two clusters. One cluster is A, B, and E, and the second cluster is C and D. Okay. So always look at the branches from the top. That will give you an idea of how many total clusters are there in the final algorithm. Okay. And if you see in this case, there are three branches, right? This is the first branch indicating a cluster of 2 points, second branch indicating a cluster of 2 points, and third branch indicating a cluster of 2 points. Okay. So always when you have to count the number of clusters or you want to find out the value of K, which is number of clusters, you have to always start from the top. Got it?
But we just
Yes, sir.
discussed that if we have 5 points like that, then AB will be the first cluster, CD will be the second cluster, and E will be the third cluster.
No. This is a separate example. This is separate. It's
No,
not that
no.
example which
In
we
the above
discussed.
previous example, just we have discussed now. So there, yeah, in
No.
this case,
See, E is not the third cluster. In this, we are using this example. This one. Sorry, we are using this example. E is not the third cluster here. This is the example we are using. This one. Okay. So instead of AB,
okay, okay,
yeah, we are doing this instead. We are basically doing ABE, which is one cluster, and CD, which is second cluster. So we have only two.
okay,
Okay.
okay, okay. I
If
get
you want the third one, then it'll be very like little be like this. If E was a separate cluster, then it would be like, I'll just show it here itself. It would be like this. Let's erase all this.
But then there will be three branches.
Three branches. Yeah, it'll be like this. So let's erase the
Okay,
F. Ignore the F. Okay, let's do it like this.
okay,
It'll be like this. Okay, this will be there, and then one branch will go to E. It'll be like this. Okay, so this is the first cluster of AB, second cluster of CD, and third cluster of E. Three branches. Okay.
okay, okay. Got it, got it.
Yeah. Okay, so this is done. So shall we implement it now? Shall we go to the code part? Code part is very simple. It's just like key means, nothing else is there.
Yes, sir.
We implement this. Okay. So again, can you tell me the library where we find clustering? All the clusters. Dot cluster, right? sklearn dot cluster.
Yes, sir.
Yeah. So let's go to that. So what we'll do is we can take the same data set, right, which we used for last class. We'll take this only. Let's run these two, in fact. Okay, so data frame is there. So let's just print it to verify. Yeah, so we have the same age income, right, which we saw in the Monday session. So we'll, instead of doing k-means, we'll do the hierarchical on this. Now, if you remember, we have to do something first, right, before clustering. There is one good thing that has to be done to make the convergence better. Can someone remind me what that was? Scaling, right? To make sure distance computation
Yes,
is
sir.
done, right? So that's what we'll do.
Yes, yes.
So let's
Centered
do
distance.
standard scalar. Yeah. So from sklearn dot pre-processing import standard scalar, right? So that let's import it. Then we'll just create a class of standard scalar and we'll do the fit transform, right? This is what the same thing we did last time also. So now our data is fit transformed. So let's see the data as well once to make sure it's scaled. And you can see it's scaled, right? Everything is from -1 to 1 and around the same range, which means that we have centered it and we have done the standardization, right? Now, once this is done, we'll import the model and we'll straight away build the model, right? So from sklearn dot cluster, even import agglomerative clustering. Okay. Once we have imported, we'll just create a class, right? Everything. So class, fitting, everything, all the things are same. So let's create a class of agglomerative clustering. So let's call it AG's cluster is equal to class of agglomerative clustering, and we will specify the number of clusters. So let's say n clusters. Let's do 2 clusters only for now. So n clusters is equal to 2, right? And then same thing, we'll do AG cluster dot fit, and we will fit the x scaled on it, right? The data. Okay, so now with this blue box, you can confirm that the model has been fit. And now what we'll do is we'll do the simple evaluation. We'll see the inertia, we'll see the labels and everything. Okay, so again, what you can do is you can just go to the model and you can just do the same attributes. All the things, code is same. There's nothing different here, just that the model name is changing. Everything else is same. So let's see the labels and let's see what the clusters have been. So you can see that the first point, the last, second, the third last and fourth last point, these belong to one cluster. All the middle points and the ending points belong to the other cluster. So we have 2 clusters, right? In case we take 3, let's try with 3 as well. So now we'll do this. Okay, so these points belong to one cluster, these points belong to the other cluster, and only this point belongs to the third cluster, right? So only one single point. Okay, then you can also see other attributes here. So let's do AG cluster dot inertia. Inertia is not there for this. Okay, so inertia is not this. I think we have to do shell out score to see the measures. Inertia is not available for this one. Or is it available? Check again. Yeah, it's not available. So we don't have inertia measure here. So we can do shell out after this, the other measure. We can also see some other attributes like which are useful. One is this labels, which is more useful. The other one you can see, you can talk about linkage, right? So we can see what linkage is. Now linkage means very simple. There are two attributes of linkage. You don't have to focus on this. One is called as word linkage and one is called as sum linkage. So what this linkage means is that this averaging, right? So if you remember what I just told you a little time back, that when you compute distance of AB with C, it is the average of distance of A with C and B with C, right? So this is what word linkage means. It is average. If you do sum linkage, it will just take the distance of sum of A with C and sum of B with C, and that is not very useful. That's why we use a default word linkage. Okay, that's a distance measure. Nothing else. Yeah, anything else? I don't think anything else is required. This
Sir,
one.
could you please explain linkage again?
Linkage
Yeah,
is just
what?
the distance computation method. So WOD is the default. That is what we will always use. It simply means that when you compare the distance of a merged cluster, which is AB, with a point C, it is the average of distance of A to C and B to C, which we just discussed few minutes back, right?
Okay, sir. Okay.
Yeah. That means what? The other one is sum linkage. That basically means you take sum of distance of A to C and B to C. But sum is not useful, right? Then always the pair will give you more distance because it's a sum. So always the distance will come higher, right? So it's not very useful to measure with that. That's why we always take average. Okay. That's
Okay,
what,
sir.
yeah. But you don't have to go into the details of these. These are not very important. For agglomerative clustering, only the important thing is the dendrogram and the process. Okay, the code part is same as k-mean. There is nothing new. Inertia is not here, so we can't measure the inertia. Rest everything is same. So there's no point in going much into that. Let me just check if there's something else which is required.
A dendrogram will not be created by the code.
No, we have to again do the thing. We have to create it by
Okay.
writing.
Only we can do this agglomerative clustering only.
Yes, we can do, and we can see which point went to which cluster. That we can see.
And
Let's see
what
what
type
is
of
done.
data points are required to be cleaned before the pre-processed?
Yeah, scaling. We have to scale it. Okay, because see,
All
yeah,
pre-processed data is required for this, no?
yes, scaled. It has to be scaled because again, it computes distances, right? And last time we discussed that any algorithm which has distance computation, we have to scale the features, right? So for this also, we have
Correct.
to do the scaling.
Yeah, first it is required.
First is because we are again like distance computation is different, but we are still computing distance, right? So the scaling becomes a prerequisite. We have to use it to make it
Mm.
better. Actually, if you don't scale, it will still work. It's not that it won't work. It's just that it will not converge very well. For small data, it's fine, but when you have large real world data, the convergence is not good without scaling. So we should always scale. Okay, so that is done.
And
Yeah,
the
I think
parameters of
that's
agglomerative cluster, this is only one
n
parameter.
clusters.
This n
Yeah. There are
only
other parameters,
one,
but those are not required. N clusters is
not
the only
required.
one which you need. Yeah, those are not used. Random state is there, but rest anything is not required. Rest you
And
can leave it.
these levels are the number length of the levels are the number of clusters.
Number of clusters. Yes. Rest anything is not required. There's one more parameter, I remember, range, but we don't use it anymore. That is basically for scaling, but we already have scaled the points, right? So we don't need to use range. So you just follow
Okay.
this method. First you scale and then you use n clusters. That's it.
And what these levels indicate?
No, labels are the clusters, right? So that means the first point went into cluster one. This point went into cluster one. This point went into cluster one. These points went into cluster zero, and this only point went to cluster two.
Okay.
Yeah,
This is
same
saying
as
the
K-means, right?
okay.
We had the labels there as well, and which point went to
This is
which cluster. Same thing.
mapping of
Mapping,
the.
This is basically the output mapping. So I'll just mention it here. Output map.
Sir, for this, there was a one distance threshold. Is that important?
No, nothing is important. Only this labels is important. That's it. Nothing else. Okay, even this linkage you can ignore, but this is I just wanted to explain that what the distance linkage means. It just means the computation of distance. Nothing else. Rest is same.
Okay, sir.
Okay, so that's what I was telling you for k-means, and the code part is if you just know the k-means code, the agglomerative is just same as it, nothing different. And the only thing is how the algorithms work that you should know, because for here the theory part becomes important. Okay, so that is important. Know the theory well. Yeah. So for agglomerative clustering, there is no elbow method you can do, but since there is no inertia, so there is no point in going into elbow method. So it is just that you can use standard clusters like 3, 4, 2. These are standard numbers, and we don't do much of elbow method and those things here. Elbow method is more used in k-means. Agglomerative, the cluster number is specified always. You don't have to find out. Okay, so yeah, I think that is done. Any questions on this? Same code, nothing different. Any doubt? All good? Just give me a thumbs up if everything is understood, then I'll assume that it's clear. Okay.
So here how we can do fine tuning.
No, no. Why will you do fine tuning? Fine tuning is for deep learning model. It's not for these ones. No, are you asking about hyperparameter tuning?
Yes, sir.
Yeah. Hyperparameter tuning, you don't need to do for this. Actually, agglomerative cluster, the hyperparameter is only this one, right? 10 clusters. How many clusters you want? In k-means, we have discussed two things. That is, one is that you can do the elbow method, right? This elbow thing, which is this one. And see the inertias and compare, right? That was what we discussed. The second method was that it k-means and clustering is a business problem. So the business owner will tell you that I want to group my customers into three baskets, right? So obviously you will know that n clusters is equal to three, right? So agglomerative clustering is always use case based, and the number of clusters is already always specified as a business problem. You never have to find out the number of clusters. Okay, so you just have to group your data into two clusters or three clusters. It will be given by the business owner, whoever gives you the clustering problem. So you don't have to find out and fine tune the parameters. Okay, it will always be given to you.
Okay, sir.
Okay, yeah. Like suppose for example, I was giving you the example of speech. I tell you that I have given you 5 audio clips and you have to group which one is Shayan's audio clip and which one is Disha's audio clip. So you know, right, there are two clusters, one is for me and one is for you, right? So it's already specified.
Yes, sir.
Yeah, so it will be all the use of hierarchical or agglomerative clustering is always in problems like speech, like this problem which I just gave you an example of. This is called as speaker diarization. You will see it in degree level in detail. So this is a very popular problem for YouTube subtitling and everything. So that is where they use this kind of a problem a lot, right? And they identify who spoke, and the same person will have similar speech attributes, right? So his will be grouped, and the other person will be grouped in his attributes. So, and that is how you are able to cluster them. Okay.
Okay, sir.
Yeah, so that was it. So yeah, I think that is it. I'll give you the collab link again with the updated things. So let me just share it. And rest is similar only. So yeah, so any other questions? That is it from my side. Like week 9 is done. I told you week 9 was a very easy week only. So week 10 is a little heavier than this because it has time series analysis. We'll have to spend some time, but it's good. It's after quiz 2, right? So you'll be free that time. So we can take a better, like longer session during week 10.
Okay, sir.
Yeah. Any other question? Any doubt anyone has with any topic of week 9 or any other week? Regarding the OPP, I have already told. So that will be a classification OPP. So those who are not there, I'll just repeat once. You will have 10 questions of pre-processing and around 10 questions of model building. Model building will be classification. So prepare the week 7 and 6 well. And pre-processing is 1 to 3. And that's the original one only. So nothing different in that. Only classification model. So prepare them well, and the rest is all the same. Yeah. Any other question? I think someone was saying something. I just missed out.
Yeah, I was saying that if you can repeat that FP and TP thing that that you have given so very well. So if you can just repeat once.
FP and TP. Acha,
So
that
very good.
week 7.
Yeah, week 7. I
Okay,
missed that.
I'll repeat that. So which part of that? I had shared a doc, I think, right? For that. I had noted it down in some
The
doc.
formula that you have written 3 lines actually.
Yeah. In one
We need to
document I had
remove
written some lines.
yeah, we need not to like write a
So
formula for that. So those things I missed somewhere.
I think this one was a doc. Probably. Yeah, this one. I'll just share this also with you. Metrics. Yeah, please prepare this. I'll tell you one thing for week 7. Please prepare this doc very well, okay? Because the end term questions from week 7 are more theory oriented because week 7 does not have much of coding, right? So these things should be clear to you how to compute what. This is a quite an important doc. Yeah, which part you want me to explain? Can you tell me which one?
Just quickly summarize once that I have this in my mind, but just I forgot.
Okay, so what is TP? TP simply means true positive. So true means correct, right? So it is actually a positive, it's actually a 1, and I have predicted it correctly to be a 1 as well, right? So how many TPs are here? This is a TP, right? The first one. This is a TP. This is a TP. And
Yes.
this is a TP, right?
Yes.
3 TPs because they are actually 1 and I have predicted them to be 1 as well. What is TN? True negative. That means actually a 0, prediction is also 0. True means correct. Okay, that you have to
Mhm.
understand. So actually a 0, predicted to be a 0. So how many can you tell me from these are TP,
Three.
TNs? 3, right? The second
Hmm.
one, last one, and this one.
Hmm.
False positive means it has to be a 1, right? But false, that means it is actually a 1. Sorry, it's actually a 0, but falsely I've given it to be a 1. False positive. Okay, that means this point. It is actually a 0, but my model has predicted it to be a 1. Falsely positive. Okay, so this one is a
Mm-hmm.
false positive. And final one is false negative, opposite of that. It's actually a positive, but I have falsely told it to be a negative. That means the actual prediction is a 1, but my model has falsely got it to be a 0. That means this one, right?
Yes.
True is 1 and prediction is 0. Okay. So this is the thing. This is basically the confusion matrix, right? This contains all these things. So this is your, yeah, I've written it here, right? So confusion matrix. Then we have some metrics which can be derived using this confusion matrix. One is accuracy. Accuracy is very simple. How many predictions are correct? So you can forget all this. You can just count out which all match, right? Those are correct predictions. So 1, this is correct, this is correct, this is correct, this is wrong, right? Because this 1 is 0. This is correct, this is correct, this is wrong, this is correct. So what is accuracy? Total correct, but
6
6 by 8.
by
By 8.
total.
Yeah, which is by 8. So I think we have solved all these, right?
Yes.
Yes,
I
I
get
believe
confused
we
when
have.
there
Which by 8. Yes.
I get confused when there is a matrix given for it.
See, matrix, yeah, I can understand. So in matrix, like, let me see if there is something, some image here which we can take. In the exam, it will be like an array only, so you can ignore the matrix for now. But yeah, in the OPP and all, you might have to plot matrices. So let me like show you something here.
Especially when there is a 3x3 matrix and we are having a diagonal elements only.
Yeah, I can understand. That is confusing. Sorry, let me check it here. Like if we get something. This is actually given in a very bad way, so it will be even more confusing. Yeah, this is fine, I think. Let's take this. So see, when you have a confusion matrix, the one thing, okay, where is this gone now? Let's take a 3x3 example only. That will be easier to understand then. Yeah, this one. So basically there are 3 classes, right? Negative, neutral, and positive. On your row, it's always actual, and on your column, it is prediction. Okay. So when you see the diagonal simply is correct ones, right? Because they are matching. So this is matching, so it's a diagonal element. This is matching neutral, and this is matching positive, positive. So diagonal means all the predictions are correct here. Okay. So if I want to ask you how many true positives are there? Now see, in what happens in 3
Those
cross
are
3?
actually rows are actuals, right?
Actual, yeah, this is
And
actual.
columns are
These are predictions. That means,
predictions.
let's see what is this 300. This 300 means actually the label is negative, but I have predicted it to be neutral 300 times. Okay, actual negative, prediction neutral 300 times. What about this 100? Can you tell me what this 100 means? This one.
Actually neutral, but
Predicted to be
predicted
positive, right? So that means it was a neutral review, but I have told it's a positive review.
positive.
Error,
Yes.
right? What about this 300? Actually positive,
Positive
prediction
and
is
predicted
positive again.
positive.
It's correct.
Correct prediction, right? So just remember one thing, diagonal may always, both the things will match, right? So that
Three
means
things.
diagonal is always correct. Okay. So suppose I tell you from 3x3 will not ask you precision and recall, because that will be a very complicated thing to do. So generally from 3x3 accuracy can be asked. So what is the accuracy? Accuracy is correct predictions by total predictions. So how do you compute the accuracy here? What's the trick?
So sum of diagonal
By sum of
elements.
everything, right? Sum of diagonal, which is the correct predictions, by sum of everything, which are all the predictions.
Yeah.
Right? Simple.
Mhm.
Okay. And suppose let's see 2 by 2. 2 by 2 will also show the same thing, right? It will be just a shorter version. Spam. That means actually spam, prediction to be spam. So correct.
Mhm.
This is actually spam, but I predicted it to be non-spam. So it is wrong, right?
Mhm.
This is again correct, right? Non-spam. So when I have to compute accuracy, it will be 600 plus 9,000 divided by the whole thing, which is 600 plus 300 plus 100 plus 9,000, right?
Mhm.
Which is 10,000. Okay.
Okay.
Same thing. So if I say like this is 94% accurate, right? No, 96% accurate, because 9,600 divided by 10,000. So 96% accuracy is there in this matrix. Okay. So make sure what you do is you read the actual one and the prediction one. This you need to be clear with. Which is the actual, which is the prediction. Then you can just match it out, right? Do the grid crisscross matching, and then you'll get the idea of what it is. Okay.
Okay. Thank you. This
Yeah.
line gives me help. Like
Yeah,
rows
so you
actuals
can
and
just, I'll
columns
just
are
share this
predictions.
website. You can just visit this once again. They have explained it quite nicely. I'll just share it here. Okay, and the doc, please go through the doc once again for your line, not right now, for your end term, because that doc contains all the formulas. So those formulas are important. You have to practice them. Okay. Yeah, Disha. Yes.
Which doc you are
talking about?
This one, where the week 7, the one I had used in week. This one. I'll just share it again.
Please share it again, sir.
Yeah, I'll just share it. So, one second. Yeah. So this is the doc. Okay, this is for week 7. Everything like
Yeah.
all the theory part of week 7, it will be there inside this. Yes, Disha.
Sir, how we can calculate precision for 3 cross 3 matrix?
So you will be given a class for doing that, but right now it is not required. You can ignore it for now. Okay. So for 3 cross 3, we don't calculate precision directly. We calculate precision for all the classes and then we average it, but you can ignore it. Right? It will be a little confusing. So for right now, you can ignore it. Maybe after your quiz 2, we can take an example during one revision session and discuss how to do that. Okay.
Okay, sir.
Yeah. So a precision focus more on 2 cross 2. 2 cross 2 precision, accuracy, F1, all the metrics which we discussed, that you focus on. Rest for 3 cross 3, focus on accuracy, calculating true positives and those things. That's the simple ones. Okay. But I'll take one more example. When we do a revision session for NTEM, I'll take one numerical example to explain everything once again. Okay.
Okay, sir. Answer for K means clustering, how we can calculate correlation.
You don't need correlation, right? Okay, means like a correlation in what sense? Like about different clusters, like how they are correlated and all.
Sir, 1 minute. It
Yeah.
was there in practice assignment 9.1.
Can you share the screen because actually my portal access again is not working due to some
Okay,
reason.
sir.
Yeah. I'll just stop sharing. You share once and we'll see what to do. No, this is actually just a pre-processing question. This is not using k-means. Okay, this is just first you have to just pre-process. Okay, and then k-means after that. Yeah, they have given it in a little wrong way. It is pre-processing question. This df.core, right? The one we saw in week 1. Same thing.
Okay, sir.
Okay, so they have mentioned actually train the model with k-means and then the question. It's actually first do the pre-processing and then train it with k-means. Okay, so it is a pre-processing question. So you remember that, right? In week 1, we did the df.core and we
Yes, sir.
solved.
Yes, sir.
Yeah, this is that only. You don't have to apply k-means. Then after that, it's k-means. They have not mentioned it clearly in the question, but no, in the OPP and all, it will be clearly mentioned. Like OPP, the pre-processing is separate only, right? So there will not be any confusion in that. This is direct pre-processing. Okay, so you just learn the df.core and you find the value, it will match the answer. Okay.
Okay, sir.
Yeah, and for OPP, please practice the PAs and GAs. Okay, that will give you a good idea. Like OPP will be similar to OPP one only, right? The same thing, but it will be just that you have to be good with the practice part. Okay, just like in OPP one, practice was important, right? Same thing for this one as well.
Okay, sir.
Session,
Sir, could
I
you
requested,
please?
sir, a session for pre-processing part, sir.
Yes, I
Proper.
have told that to the
Yes,
DS.
sir.
This week was quiz 2, so this week we did not do that. Next week we will do it.
Yeah,
Pre-processing session.
proper way
Yeah,
of
it will
doing
be
how
from
to do.
proper pre-processing. I think two
All,
sessions we can have for that.
yeah, so that we can tackle any type of data.
Yes. We will do that. I just told them not to do it this week because there was quiz 2, right? So we'll not do extra things this week. Next week we'll be doing that in week 10,
Okay.
right?
Okay.
And we'll also like practice some other pre-processing methods like the feature selection methods. Like we have only practiced PCA, like recursive feature selection. Those things also we'll do practice because in OPP2 those things might be there. So we'll practice those things as well. Like all the pre-processing end to end. I'll tell we'll cover everything in detail with different types of data sets so that we get a good idea of how it is to be
Yeah,
applied.
yeah, because we think pre-processing creating, I think, problem for us because
Yes, no
due
worries. So
to,
next week there'll be
yeah,
2 sessions for that. Good
okay,
session. We'll end to end. We'll cover pre-processing.
yeah, please,
Yeah,
thank you.
Okay, sir.
sure. Okay then. So we can wrap up for today. Week 10 also we'll cover next week. Until then, all the best for quiz 2. So we'll meet on Monday with week 10. Okay.
Okay, thank you.
Thank you everyone. Thank you. Good night.
For MLP, we don't have quiz too, right?
No, MLP you don't have quiz 2. Only NTERM is there. OPP2 and NTERM. Okay.
Thank you so much.
Yeah. Okay. All the best. Thank you.
Thank you, sir.
Thank you. Yeah, Disha, any question?